In fact, this is, in my opinion, also the strongest argument for intelligent design, because if you don't believe there was intelligence involved in the creation of life or the evolution of human intelligence, you essentially believe that the fundamental unintelligent forces of physics alone could have rearranged the basic particles of physics into computers, jet airplanes, and smartphones.
ID, the Future, a podcast about evolution and intelligent design.
What does a mathematician have to say about the effectiveness of Darwinian evolution? And in what ways does the development of life on Earth mirror the development of human technology? And how does this lend support to the case for intelligent design in biology? Welcome to ID the Future. I'm your host, Andrew McDermott. Today, my guest is mathematician and author Granville Sewell to discuss some of his intriguing arguments for intelligent design as detailed in recent articles, videos, and books. Sewell is an emeritus professor of mathematics at the University of Texas, El Paso. He has also been employed by Oak Ridge National Laboratory, Purdue University, Universidad Simón Bolívar in Caracas, Texas A&M University, and elsewhere. Sewell has written 4 advanced mathematics books, a widely used finite element program, PDE-2D, and the book In the Beginning and Other Essays on Intelligent Design. Welcome to the podcast, Granville.
Thanks for the invitation.
Absolutely. It's good to have you back. I know it's been a little while since we heard your voice on the podcast. I think the last time you might have been promoting your book with Discovery Institute Press, In the Beginning. And you've been stewing on a lot of arguments for intelligent design, some really interesting and intriguing ones for a long time now. And we're going to unpack some of that. First, I want to take our audience back to the year 1985 for a few minutes. The iconic time travel movie Back to the Future came out that year, one of my favorites. This is 6 years now before Discovery Institute was founded in 1985. 6 years before Discovery Institute. The term irreducible complexity, still 11 years away from being coined by Michael Behe, although the idea is already simmering. The modern intelligent design research community has not yet come together. And although there are rumblings of a revolution in 1985, you could be forgiven for thinking you were on your own, as someone who was thinking through these issues. But one of the big rumbles came with Michael Denton when he published his seminal book, Evolution, A Theory in Crisis, that year with Burnett Books in the UK. And another book was published that year from Springer called Analysis of a Finite Element Method by Granville Sewell. Now, in the postscript to this book, you said this: I am intrigued by the analogy between the 11-year evolution of this computer code and the multi-billion-year history of the genetic code of life, which contains a blueprint for a species encoded into billions of bits of information. So again, that's from the postscript to this book that you published in 85. Now, tell us more about what you were seeing back then and the fallacy it reveals about Darwin's explanation for life.
Well, it's interesting that Michael Denton's book was published in the same year. Of course, his book was very impactful. It influenced the thinking of Michael Behe and others. My postscript was probably not read by anyone except users of my software. It was sold commercially in Houston by a small company. Mm-hmm. But the analogy itself I've used frequently since then. The development of my partial differential equation solving software, which was 10 years old then, it's 50 years old now, proceeded step by step, but not really gradually, because the major steps, for example, going from steady state problems to time dependent or eigenvalue problems, later would go from solving 2D problems to 3D problems, adding a new linear system solver, going from solving one equation to multiple equations. All of these major changes required adding hundreds of lines of code, none of which made any sense or provided any advantage to the code by themselves. So until these hundreds of lines had been added, or most of them, nearly all of them had been added, there was no way to even tell where we were going with it. Uh-huh. And the interesting thing is we see the same pattern in the development of life in the fossil record, large jumps where major new features appear, new phyla, new classes, new orders, and smaller gaps where less major features appear, new families, genera, or species. And I quoted in this 85 book, Harvard paleontologist George Gaylord Simpson writes, "It is a feature of the known fossil record that most taxa appear abruptly. They are not, as a rule, led up to by a sequence of almost imperceptibly changing forerunners, such as Darwin believes should be usual in evolution. This phenomenon becomes more universal and more intense as the hierarchy of categories is ascended. Gaps among known species are sporadic and often small. Gaps among known orders, classes, and phyla are systematic and almost always large. These peculiarities of the record pose one of the most important theoretical problems in the whole history of life. Is the sudden appearance of higher categories a phenomenon of evolution or of the record only due to sampling bias and other inadequacies?" So it's interesting. We see the same pattern of large jumps where major new features appear in development of software and in the fossil record. And in this 85 book, I wrote the following, quote, "The famous problem of novelties is another formulation of the objection raised here. How can natural selection cause new organs to arise and guide their development through the initial useless stages during which they present no selective advantage?" The argument goes. The Darwinist is forced to argue that there are no useless stages. He believes that new organs and new systems of organs arose gradually through many small improvements. But this is like saying that PD2D could have made the transition from a single partial differential equation to systems of partial differential equations through many 5 or 6 character improvements, each of which made it work slightly better on systems, end of quote. Now, if you wonder where I got the 5 or 6 characters, I was very generous, and I said, assume that you have 1 billion programmers typing out 1 random character per second for 4.5 billion years, the age of the Earth, then it's easy to show that there's virtually no chance that any one of them would ever produce any given 20 character improvement. So I thought 5 or 6 seemed like more or less the limit of what could be accomplished by chance alone.
Now, this is so interesting that you were recognizing this as a programmer and a budding mathematician back then. But not surprising, I would say. Now, you continue to make this argument that the history of life resembles the way humans create and invent. Large gaps between major innovations, the same technology being developed independently, and even inventions bearing similarities due to common design. You use the example, I think it's a good one, of the steam engine and the internal combustion engine. The steam engine was refined through small changes over time, but those small incremental changes to the steam engine did not produce the internal combustion engine. That required an infusion of new thinking, a major jump in the technological record, so to speak. Now, this mirrors what we see in the history of life, right?
Exactly. There's no way to transition gradually from steam engines to internal combustion engines without development of new but not yet useful features. That's like the development of software. You can't get from 2D problems to 3D problems you can't get there gradually without introducing meaningless lines of code. And same thing, I think, with probably any type of human technology, you'll see the same pattern of large gaps where major new features appear. For the same reasons, if it were gradual, there would be new features developing through their useless stages, and that wouldn't make any sense. The only thing that could see these useless stages through to the useful stages would be intelligent design. And as they pointed out in the minute ago, that the development of new organs or new systems of organs which gave rise to new phyla, classes, and orders was not gradual for the same reasons. It would have required the development of new but not yet useful features. And really, I use the example of development of software because I'm more familiar with that, and it's easier to quantify the size of steps. I think you'll see the same pattern in the development of any human technology, large gaps where important new features appear.
Yeah. It's a simple point, but it's a very, very important one, I would say. So is it fair to say that jumps are essential when it comes to large-scale innovation?
Yes, I think so. I mean, you could always do it gradually. And in fact, I guess I did add a few lines at a time when I was going from 2D problems to 3D problems, but I knew where I was going. You couldn't do that through random.
Yeah. And that's key. That's the key. You knew where you were going.
Exactly.
Foresight. Natural selection doesn't, right?
And also, one thing I was going to point out is that Darwinists usually, when they're faced with something like this, the big gaps between major groups, they'll try to find one or two useful intermediate steps, but that doesn't really solve the problem, even if they can imagine a few intermediate steps. The point is you can't get there by very small steps. You can't design complicated software a few characters at a time. You have to be able to look ahead.
Yeah. Now, you mentioned an example of convergence in human technology, and it's a car company like Ford developing GPS technology for their cars at the same time as, say, Boeing is developing it for their airplanes. That's an example of convergence in human technology. Now, you also mentioned an example in your teaching and videos of convergence in the carnivorous plant world. I wondered if you could just highlight that for us and let us know what it suggests about the history of life.
Well, that actually comes from a paper published by Linisch and Becker on carnivorous plants. They point out that the pitchers may have arisen 7 times independently, adhesive traps 4 times independently, and so forth. So it's actually very common. If you ask me do you believe in evolution, instead of trying to explain that there are several different definitions of evolution, I think the best answer I could give is that I believe in the evolution of life and the evolution of automobiles, but I don't believe either could have happened without design. And this is actually a very informative answer, because the similarities between automobiles or any other human technology, I give the examples of automobiles because it's more familiar to everyone, I guess. But they develop step by step, but with large jumps where major new features appear. But convergence is another way in which the development of life is similar to the development of human technology. And convergence suggests common design rather than common descent. The probability of similar designs arising independently through random processes is very small, but a designer could take a good design and apply it several times at different points in the evolutionary tree to distantly related species, for example, to give whales and bats echolocation abilities. In fact, this is very interesting because convergence is so common that it confuses and almost destroys the evolutionary tree. Cornelius Hunter has pointed this out. Winston Ewart has published in Biocomplexity a paper showing that looking at genomic data, he's shown that the evolutionary tree is not really so much a tree as it is a dependency graph. Messes up the tree. And the interesting thing is it does the same thing with human technology. For example, if you look at automobiles, you could kind of make a general tree, Ford's over here and Chevy's here or something. And, but there's so much convergence there that it'd be hard for even the designer to say what was the ancestor of a certain model of Ford. Because it got ideas from many different, automobile lineages. And we see essentially the same thing with the record of life, the evolutionary tree. It's not really so much a tree, as Ewart says. It's more a dependency graph like you have with software, and it's just very much like what you would expect with intelligent designers.
Yeah, and by the time you're done, it can look more like a gnarly forest instead of just a single elegant tree. Now, you have another illustration that I wanted to unpack here as we're talking about, the similarity between human technology and the development of life. You have an illustration about what it takes to produce a technological civilization. You show a picture of a barren landscape on an Earth-like planet. Then you show a picture of a planet at the height of its civilization, with tall skyscrapers full of intelligent beings, computers, and the like. Now, to get from one to the other, some would say a collection of atoms formed by pure chance, learned how to self-replicate and pass their complex structures on to their descendants, and eventually something called intelligence emerged that allowed some of these atoms to design these things, buildings, computers, write encyclopedias. But this scenario is extremely improbable and seems to violate the second law of thermodynamics, whether or not the Earth is considered an isolated system or an open one. After all, natural processes tend to turn order into disorder. Now, why would Darwinists believe that natural selection is the one unintelligent process in the universe that can create spectacular order out of disorder.
Well, that's well spoken. In my 2000 Mathematical Intelligencer article, was divided into two parts. The first part is basically the same argument as my 1985 postscript, and this did get a lot more attention than my 1985 book. The second part, I made an even simpler argument, which I'm going to talk about now, the one you're referring to. And there's something very unnatural about computers and jet airplanes and civilization arising on a barren planet, but does it violate any law of science? Well, the only one that it could violate is the generalized second law. Okay, the second law of thermodynamics was first applied to heat to say that heat distributes itself more randomly, more uniformly in an isolated system. But then it was generalized to say that, for example, one physics textbook says the following: in an isolated system, the direction of spontaneous change is from order to disorder. Well, we're all familiar with that. We know that everything tends from order to disorder. Michael Behe talks about devolution. Darwinism actually causes devolution, not evolution. But ID opponents, when you try to make this argument, ID opponents say the second law only applies to isolated systems. The Earth is not an isolated system because it receives energy from the sun. End of story. The second law doesn't apply here. But why can't order increase in an isolated system? Because it's extremely improbable. Are the laws of probability suspended when a system is open? No, you just have to take into account what is crossing the boundary when deciding if an increase in order is extremely improbable or not. So right. In several publications, I wrote the following: if an increase is an increase in order is extremely improbable when a system is isolated, it is still extremely improbable when the system is open, unless something is entering which makes the increase not extremely improbable. That's basically not only common sense, but it's a tautology. The fact that order can increase in an open system does not mean that computers can arise on a barren planet as long as the Earth receives energy from the sun. Something must be entering the open system, which makes the appearance of computers not extremely improbable, for example, computers. But they aren't impressed by that argument. The Darwinists, they come up with all sorts of objections. I've heard that the second law should never have been generalized. It should only apply to heat. Too hard to quantify entropy. Well, that's true. And ultimately, most people get confused by all this. Entropy is a very confusing concept. So finally, I've kind of given up trying to get that across, and I just finally stick to the argument that unintelligent forces of physics alone cannot rearrange the fundamental particles of physics into computers and iPhones, etc. And if you think they can, the second law argument won't help you see the problem. I begin the argument, the second part, in the 2000 Mathematical Intelligencer paper, saying the other point is very simple, but also seems to be appreciated only by more mathematically oriented people. But this is not because it's too complex to be appreciated by other scientists. In fact, you might say it's because it's too simple to be appreciated by others. And if you watch the 7-minute video, A Mathematician's View of Evolution, which is linked from the second page of ChristianityForDoubters.com, where I imagine a gigantic computer model which attempts to simulate what has happened on Earth, and you'll understand what I mean. One more thing about this. The only mathematical contribution I've made in several publications, including a 2017 Physics Essays article and a biocomplexity paper and several others, to the debate is show mathematically that thermal entropy in an open system cannot decrease faster than it is exported, i.e. the thermal order, if you define thermal order to be the opposite of thermal entropy, cannot increase faster than it is imported, and the X order cannot increase faster than X order is imported, where X is heat or carbon or anything else that diffuses. So really the equations of entropy change don't support the illogical compensation argument. Instead, they illustrate the common sense conclusion above. This is presented also in another video link from the Christianity for Doubters second page, Why Evolution is Different, which also contains much of the material of chapter 2 for this new book. I got pretty discouraged that so few people seem to appreciate such a simple argument. I think it's just too simple for many scientists. And but one well-known mathematician, who I don't want to identify at this point, wrote me. complained to him that I was discouraged that people don't see the obvious here. And he wrote me, quote, "It is a good argument and one I've noticed that elicits very little by way of serious counter-argument," end quote.
And that's that an unintelligent process cannot bring about the order that we see. You can't go from disorder to order.
Yeah, exactly. If you believe that the origin of life and the evolution of life and the evolution of human intelligence is entirely due to unintelligent forces, as Darwinists do and any materialist does, then if you just think about it, what you're basically saying is that unintelligent forces can rearrange the particles on Earth into computers and jet airplanes and so forth. And that's what that video is about. And it brings that out in a clearer way.
Yeah. Yeah. One of the lines in your video is mathematicians are trained to value simplicity. And it seems counterintuitive at first. We think mathematicians are just thinking about all these complex things and way too hard for us to understand, the common person, but they actually can appreciate simplicity and catch it even when it's missed by others. Is that what you're saying?
Yeah, I give an example in that 7-minute video, Mathematician's View of Evolution, which is based on the Mathematical Intelligencer article of the same name. Give an example of how a complex problem, a problem that seems very complex, can be solved in a real simple way, and that's what mathematicians are used to doing.
Well, one of your latest projects is the release of a second edition of your book called Christianity for Doubters. The first 2 chapters deal with intelligent design, so I thought we could review some of your insights. First, in chapter 1 of the book, you remind readers what intelligent design is and what it isn't, and I think that's pretty helpful. Can you review that with us?
I basically define intelligent design by explaining what you have to believe to not believe in intelligent design. If you don't believe in intelligent design, that means everything that happens is due to unintelligent forces. So you believe that unintelligent forces of physics alone could have created life on Earth and can explain the evolution of life and human intelligence. In fact, this is, in my opinion, also the strongest argument for intelligent design, because if you don't believe there was intelligence involved in the creation of life or the evolution of human intelligence, you essentially believe that the fundamental unintelligent forces of physics alone could have rearranged the basic particles of physics into computers, jet airplanes, and smartphones. That's the really simple argument that I've been making for 25 years now, and with limited success. The 7-minute video, Mathematician's View of Evolution, will hopefully get the point across.
Yeah.
Then I go on to, mention that most of the scientists today who call themselves intelligent design scientists accept the standard timeline for the beginning of the universe, the appearance of major animal groups, appearance of humans. For example, Steve Meyer's book, Darwin's Doubt, was about the sudden appearance of most of the animal phyla about 500 million years ago. And I pointed out that not only Christians, Jews, and Muslims really believe in intelligent design, but throughout history, nearly everyone in every remote corner of the world believed in some form of intelligent design. So we're not a fanatical fringe group as depicted by the popular media. But as the name implies, the book is not just about intelligent design. Only the first 2 chapters deal with ID, but these are critical to the book. The rest of the book is explicitly Christian and deals with the problem of pain and other problems educated people have with Christianity and the Bible. I think the book offers some important insights into these problems, but I won't go into the theology here. In my experience, these issues, especially the problem of pain, are the real reason many scientists prefer materialist explanations like Darwinism on origins, no matter how implausible they may be. Mm-hmm. So that's why I thought it was important to look at some of those problems.
Yeah, definitely. And in chapter 2 of your book, you have several sections laying out pretty clearly some of the key evidence. Now, you start by quoting American geologist Joseph LeConte in his 1888 book, Evolution. Tell us what he said about evolution being an axiom and how this view is still prevalent in a lot of scientists today.
Yeah, this is very interesting. He was quite honest in his appraisal. First, he acknowledges that the fossil record doesn't support the idea of gradual change, and I quote, species seem to come in suddenly with all their specific characters perfect, remain substantially unchanged as long as they last, then die out and are replaced by others. And then he acknowledges the so-called problem of novelties that we've been talking about, that natural selection cannot explain the first steps of advance toward usefulness, which is a major problem. It basically can't explain anything new, he's acknowledging. And yet, he says evolution is absolutely certain. The origin, if he's not talking about Darwinism necessarily, he's talking about evolution through natural causes.
Yeah.
But he says evolution is absolutely certain. The origin of new phenomena are often obscure, even inexplicable, but we never think to doubt that they have a natural cause, for so to doubt is to doubt the validity of reason and the rational constitution of nature. And here's where it gets interesting. He goes on to say, the law of evolution is as certain as the law of gravitation. Nay, it is far more certain. The former is a necessary truth. The latter is usually classed as a contingent truth. Now think about what he's saying there. He's saying that the law of gravity is a contingent truth. That means that we believe in it only as long as observation and experiment confirm it. But the law of evolution is a necessary truth. That means it's not contingent on observation or experiment. It can't be overturned by observation or experiment. And of course, we're all familiar with that. No matter what evidence we find, they will still insist. So many scientists, not as many now, not as many as 40 years ago, certainly, but majority of scientists still consider it an axiom. Mm-hmm. And if you're wondering why evolution is as certain as gravity, that's why. I wonder if this is the first time that evolution was compared to gravity. It might have been.
Mm-hmm. Yeah.
But it's an axiom. That's why it's certain.
Right. Yeah, and LeConte was just one of the voices, late 19th, going into the 20th century, that, tended to solidify Darwinism as, just full of religious fervor and full of certainty as well. Notice how he puts it. It's a necessary truth. And what he really means is it's necessary to this scientific materialism that we hold dear.
Exactly.
Regardless of the evidence. Even he says that, we might not understand how it did it, but we're sure it did it, It's amazing to have so much certainty. And yet, if we're being honest and we're being humble, we know that science is provisional. And I don't get a lot of humility out of LeConte's writing there. But anyway, there's a point you make about irreducible complexity in living things that I think is, like a number of your arguments, simple yet profound. You say that since many features of living things are irreducibly complex, and the way you define that is useless until almost perfect, gradual development of these features would be as difficult to explain as their sudden appearance. To put it in LeConte's words, an organ must be already useful before natural selection can take hold of it. There's no almost alive. An organ almost being functional. It's alive or not, it's functional or not. And let's remember that Darwinism sinks or swims on the fact that its mechanism operates by numerous slight successive modifications, according to the theory. So how does it make those jumps in complexity required for new life forms to emerge?
Well, the short answer is it can't. Mm-hmm. Scientists who've studied the waning time problem have unanimously found that multiple simultaneous coordinated mutations in animals are prohibitively improbable. So Darwinian evolution must proceed one mutation at a time. In other words, extremely gradually. You can't make large jumps by chance alone. So the only hope is that there are no useless stages. You can develop complicated things, one useful change at a time. But in the postscript that we talked about earlier, 1985 book, I offered the aquatic bladderworts as an example of irreducible complexity. Of course, I didn't use that term. These carnivorous plants are described in a 1947 book as follows. These traps have trigger hairs attached to a valve-like door, which normally keeps the trap tightly closed. The sides of the trap are compressed under tension, but when a small form of animal life touches one of the trigger hairs, the valve opens, the bladder suddenly expands, and the animal is sucked into the trap. The door closes at once, and in about 20 minutes, the trap is set ready for another victim, end quote. So Lenish and Becker, in their article on carnivorous plants, by the way, they're both were scientists at the Max Planck Institute for Plant Breeding Research. I visited with Linnish and Cologne on one of my working trips to Germany, a couple of them actually. It was a Nature Encyclopedia of Life Science article on carnivorous plants. And they say it appears to be hard to even imagine a clear-cut selective advantage for all the thousands of postulated intermediate steps in a gradual scenario for the origin of the complex carnivorous plant structures examined above. You might remember that Michael Behe's book, his first book talking about irreducible complexity, he gave an example of a mousetrap, and I posted something on Discovery's website a few years ago that said that Behe's mousetrap exists in nature. In fact, it's a lot more complicated than human mousetrap. Trying to imagine that evolving gradually is just absurd until it's able to catch the animal, digest it, reset the trap. And to begin with, it's watertight, so it has to be perfect. It has to be almost perfect. So it's a nice example of irreducible complexity. But so are all the other carnivorous plants, and so are lots of other things. Behe points to lots of molecular machines that are irreducibly complex. And so in answer to your question, it can't. And I'd like to bring out one more thing. In a 2023 Biocosmos article I wrote, Human-Engineered Self-Replicating Machines, I showed why we're not close to designing any sort of self-replicating machine ourselves. When we add technology to such a machine to get closer to the goal of reproduction, we only move the goalposts, as now we have a more complicated machine to reproduce. Mm-hmm. So not only do we have no idea how living species evolve more complex structures like new carnivorous traps, but we have no idea how they're able to pass their own current complex structures on to their descendants.
Yeah. That's also a very interesting part of the argument. Well, while Darwinists believe it must be possible to explain everything in terms of the basic laws of nature, it's now a well-documented fact that these laws themselves are highly fine-tuned to make life possible. And you do mention some of the fine-tuning evidence in your book. Tell us why the evidence for fine-tuning of the laws and the constants, as well as the initial conditions of the universe, is a major problem for evolutionary proposals.
I don't know that I would say it's a major problem for evolutionary proposals. It's a major problem for atheism. As you say, it's a well-documented fact that the laws of our universe and the initial conditions of our universe are highly fine-tuned for life. And the only alternative design seems to be wild speculation about multiple universes with random values for these fine-tuned constants of physics. And in fact, many scientists are convinced of design by this argument. It's such a powerful argument that now lots of scientists are coming over to design viewpoint, at least as far as the design of the laws themselves. But most of these still insist that the designer either could not or did not do anything beyond that. But if you believe a creator designed the laws of nature to make life possible, why exclude a priori the possibility that this creator was still somehow involved after that in the creation of humans? The forces of physics are very cleverly designed and apparently are clever enough to explain chemistry and stars and everything that's happened on other planets. But are they clever enough to, without further help from this creator, reorganize the fundamental particles of physics on Earth into humans, nuclear power plants, cars, airplanes, and smartphones? I don't think so.
Yeah.
The new edition of Christianity for Doubters in sections 2.5 and 2.6 now includes some considerable discussion of the very interesting, spectacular example of fine-tuning discovered by Roger Penrose. It's interesting because it requires an unbelievable amount of precision, and also because he doesn't use the multiverse to avoid design. In section 2.6, I include a discussion of evidence that our laws of our universe and the conditions on our planet are not only fine-tuned for our existence, but also for scientific discovery and technological progress. Michael Denton and Guillermo Gonzalez have been fundamental in that, in showing that not only our planet, but the laws of the universe. The multiverse argument basically just claims to explain, and of course it doesn't, but claims to explain why conditions are just right on our planet and our universe for us to exist. But as Behe says, the conditions, it doesn't explain why conditions in the planet are so lush, why we have things like, why it's so fine-tuned, not just for existence, but for scientific discovery and technological progress.
Yeah. Yeah, not just for our survival, but also our thriving.
Right.
Yeah.
Good way of putting it.
Yeah. And to your point, you could still argue that all of life on Earth came from an evolutionary process, but you then have this separate whole problem of the fine-tuning evidence and what it suggests. So yeah, those are two separate things, but you have to deal with them both if you want a comprehensive view of life and the universe. Now, speaking of fine-tuning, you say that the fundamental equation of chemistry itself appears finely tuned. Tell us how the fundamental particles and forces obey a very elegant mathematical equation and how it is that we have no clue why that is.
Yeah, this is something that I've brought out earlier in my discovery book, Discovery Institute Press book, and I haven't seen anybody else make the argument, but if the basic particles of physics, electrons and protons and so forth, if they interacted by bouncing off each other like tiny balls obeying classical Newtonian laws like we used to think they did, there would be no chemistry. Chemistry, the marvelous properties of carbon and so forth, is all because they interact according to the Schrodinger equation of quantum physics, which is an elegant partial differential equation. That's my field. It's a numerical solution of partial differential equations. So, there's no, it can't be derived from simpler principles. Nobody has any idea why the basic equation, which describes how the forces interact with the particles, is elegant partial differential equation, which of all things is a complex number I in it. And but another interesting thing about the Schrodinger equation is it doesn't tell us exactly what happens. It only provides probability distributions. So as Sir Arthur Eddington says, quantum mechanics, quote, leaves us with no clear distinction between the natural and the supernatural. And really no one has any idea why they obey this elegant partial differential equation. But if they didn't, we wouldn't be here. Yeah. So I kind of sarcastically said, well, maybe there are other universes where the fundamental equation of physics is second derivative when it should be a first derivative and so forth.
Right. And it's another reminder of how mathematicians can sometimes get to see this elegance. Not all of us study the deep complex equations. And so this is just another way you can see this beauty and this elegance coming together. And it does, make you ask why, why is it elegant? Why does it make sense in this way? Now, you also mention human consciousness in the science section of your book, calling it the biggest problem of all for Darwinism, but something that is seldom discussed in scientific terms. Tell us why you think it's a big problem for a Darwinian theory of life's origins.
Well, if you think, I bring up the question, do you think that computers will someday be conscious with, Chat GPT and so forth, AI? Darwinists probably do believe that eventually computers will be conscious, but most people don't. I still don't believe, no matter how clever my laptop is, I don't believe there's anybody inside it. And if you don't believe, as most of us don't, that computers could ever become conscious, why would you believe that random mutations could accomplish this? If intelligent engineers can't cause computers to achieve consciousness, why would you believe that random mutations could accomplish this? And then finally, I ended in this section with an example that seems to be popular. I found it to get across the point because it's easy to ignore human consciousness in this discussion of human evolution since it's too difficult to even describe, but we all know what it is. And in section 2.2, I try to bring the problem home where you can't ignore it by showing a picture of me and my brother and sister when we were young. I wrote, in this figure, we see a picture of 3 children in the 1950s. One of them is me, the other 2 are not. I saw the world from inside one of these children. I saw every picture that entered through his eye. I heard every sound that entered through his ears. And when he fell on the sidewalk, I felt his pain. How did I end up inside one of these children? This is a question that rarely seems to trouble evolutionists. They talk about human evolution as if they were outside observers and never seem to wonder how they got inside one of the animals they are studying. They consider that human brains are just complicated computers, and so to explain how we got here, we just have to explain how these mechanical brains evolved. But even if they could explain how animals with intelligent brains, mechanical brains, evolved out of the primeval slime, that would leave the most important question still unsolved. How did I get inside of one of these animals? And I found that seems to get the point across the problem with consciousness.
Uh-huh. Yeah, very elegantly put, I think, the problem of human consciousness. And I think you're spot on there. You know, they try to talk about the origin of complex biological life, but they're not really tackling how we got into these bodies, you know, these organisms, and had consciousness and the ability to even think about all this, you know. So Granville, you know, this is very interesting. I'm glad we can unpack some of the arguments that you've been putting out there in various forms for quite some time. You do have videos, and we will link to them in the show notes of this episode so that people can click on them. They're very worth watching. There's two in particular that we can link to, and they're great for sharing with people as well. But tell us, are there other ways that people can tap into your work?
Well, hopefully you'll also have a link to ChristianityForDoubters.com, which is the website for the new book. The first two chapters, as we've said, are about intelligent design. And the second page of this website has links to some of my videos, and the third page has a link to my Discovery Institute Press book. So that should be sufficient.
Yeah. Okay, so we have ChristianityForDoubters.com, and there you'll find two videos in particular that I enjoyed rewatching: A Mathematician's View of Evolution and Why Evolution is Different. And in those videos, he's unpacking a lot of these simple yet profound arguments that we've just been able to touch on in our chat today. So I encourage you to go and see these videos, read the book, and get a feel for these arguments, because they're great to take with you once you understand them. They're pretty simple to communicate to others, and I think they're pretty strong. Now, you also have a book with Discovery Institute Press, and that's In the Beginning, articles on intelligent design, so people can get a hold of that as well if they want to read those essays. Well, Granville, I appreciate your time today. Thank you very much for the conversation. And I hope it's not going to be as long before we have you back on.
Thank you.
Yeah, let's get you back on and keep talking about these. I really appreciate your perspective as a mathematician and as one who has programmed. It's so interesting that you started seeing these connections and asking these questions, you know, way back in the 80s when it felt like you were alone. But really, there was a community starting to brew even back then, wasn't there?
Yeah, the internet has maybe caused a lot of problems, but it's also, if it weren't for the internet, we'd still be unable to communicate with other intelligent design people. Like in the 80s, we wouldn't realize how many there were, because you certainly couldn't communicate through the science journals back then. Yeah, and the gatekeepers of those science journals did a pretty good job of keeping out ideas like this. With their methodological naturalism firmly in place. But thankfully today we have the internet, we have the ability to connect with others, but we also have these alternative ways of getting the word out about all this and about the evidence. So and we have Discovery Institute, thank goodness.
Yes, thank goodness indeed. Well, don't forget you can access Granville's videos and his books at the website ChristianityForDoubters.com. And also another reminder to subscribe to our new channel on YouTube. ID the Future has its very own channel. You can watch these interviews, many of them, not every single one, but I'd say the majority by now. We're putting out on video as well. So you can enjoy that at youtube.com/@IDTheFuture. Well, until next time, thanks again, Granville. I'm Andrew McDermott for the podcast. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.